In the previous parts of this exercise, we created the geometry parts for our model, one cylinder and one block. The simplest way to generate our computational domain is to go to the Operations folder, right-click, choose New, and then go to the Boolean category. Among the Boolean operations the software suggests, we want to use subtract. In other words, we want to subtract our cylinder from the computational volume. So we select Subtract. The first field that appears is Input Parts. This is where it asks for the parts that will be involved in this operation. The parts one want to use in this operation are the block and the cylinder. I select both of them and press OK. Next, we have Target Part. This is where the software asks, which part do you want to keep as your main target? What should remain after the subtraction? I want the block to remain, so I select the block as the target and press OK. We don't need to modify any of the other parameters for this basic case, so I just press OK again. As soon as I do that, the operation is created, and at the same time a new part is also created for us. The exclamation mark next to the part name indicates that this part has not been updated yet. To update it, we right-click on the subtract operation and choose Execute. Once we execute the operation, the software generates the new part for us. Now I can create an empty scene. An empty scene means a scene that initially has nothing inside it. Then I select the subtract part, drag it, and drop it into a new display named Surface. I press OK, click outside in the view, and now you can see the geometry that has been created. At this point, I notice something. The distance between the top and bottom walls and the cylinder is not ideal. The gap is a bit too small for my liking. So, very easily, I go back to my block part. If I look at its properties, I can change the values there. For example, I can increase the upper and lower y coordinates to plus or minus 75 millimeters instead of the previous values. When I adjust these corner coordinates and press Apply, you can see directly in the graphics window how the block has changed. Now, an important point. When you change this block, the subtract operation that depends on it is also affected. Since the operation is tied to this block, it becomes outdated and needs to be updated again. So, once more, I right-click on the subtract operation and press Execute so that everything gets updated. After this, the tool name Subtract and the resulting part are updated accordingly. If we look at the block in the surfaces list, we see that right now the block has only one surface region. Later on, when we want to define boundary conditions like inlet, outlet, walls, etc., having just a single surface will cause problems. To fix this, I right-click on Surfaces and choose Split. The Split tool has several options, which we've already covered earlier. This time, I want to use Split by Angle. What this means is that I'm telling the software, for all the faces I've selected, if the angle between them is larger than, for example, 89 degrees, then separate them into different surface regions. The software then automatically creates several surfaces for me. Since my domain is a rectangular block, the result is 6 surfaces, one for each side of the block. Now I can rename them. I click on each surface, press F2, and give it a meaningful name. For example, the surface at the back, which is on the outlet or downstream side in my setup, I might call back wall. The top surface I rename to upper wall. Another surface may be my inlet. Similarly, I assign appropriate names to each surface, front, bottom, sides, etc. As you select each surface, it is highlighted in the graphics window, so you can easily see which boundary you're renaming and choose the correct name. You can use any naming convention you like. I am using this combination of names, and I'll stick with it. Now, before I run Subtract Execute again to update everything, if I open the subtract operation in the tree, you'll see that it shows 2 folders. The second folder is called Inherited Parts. This means that it contains the parts and surfaces that this operation inherits from the original parts. Since this subtract operation is made from the block and the cylinder, both of these parts appear in Inherited Parts, along with all their associated surfaces. If I expand this folder, you can see that all the surfaces that belong to these parts are listed here. I can execute the operation again, then go into Subtract Inherited Parts, open the block, and I will see all of the surfaces I created. I can click them and see them highlighted in the scene. Now, one reason you might still see only a single surface in your active scene is that the scene itself is not updated with all the new surfaces. To fix this, I go to Scene 1, select the surface display, Then in the Properties panel at the bottom, I click the button with the 3 dots, the selection dialog. From there, I go into my Subtract part, select the cylinder surface, and then look at the block. For the block, you might see that in the selection dialog there are 2 small square icons, but only one of them is blue. That means not all surfaces of the block have been selected for this scene. I double-click so that both squares become blue, meaning all surfaces of the block are now selected. I press OK, and you can see that the surfaces in the scene are now fully updated. This is the subtracted volume that we now have, our computational domain with the cylinder volume removed. I can reduce the opacity again to make it easier to see the shape. This is the part on which you can comfortably generate the mesh and then continue setting up the simulation. To help myself later, I might also look at the cylinder surface separately and take note of its name, because I will need it when I define boundary conditions on the cylinder. You can even look at the edges, curves, of the cylinder. These are the curves you might later use for specific mesh controls. For example, when we start talking about mesh refinement near the cylinder. So, this was the simplest method for creating the computational volume you need. In the next part, we'll look at how to achieve the same goal using another option called wrapper, and see how we can use that tool to generate this volume.